Let f be the function from a to b. Is this true or false? The statement f of s minus t is a subset of f of s minus f of t, and this statement is false. This is false, and here's why. We can think of f as, we give a counter example. F function from R to R, sin x to x squared, and we can think S as a set 2 minus 2, and T is a set of only say 2. Okay, and we have S minus T is minus 2. Okay, f of S is a set of f of x in S, right? X in S in either 2 or minus 2. So this is x squared for x is 2 or minus 2. So this is x squared x in minus 2. So this set 4. That's all. And f of t, you can do it similarly. You have 4. F of s minus t is also 4 because s minus t is minus 2. So you see here we have f of s minus t, the left hand side is 4. The right hand side, f of s minus f of t is the empty set. F of s minus f of t is a set 4 minus a set 4. So this is the empty set. And therefore we see that this set, this is not the subset of this set. Because it says it's 4, not subset of the empty set. That if f is 1 to 1, then the statement is true. Then we have this. Okay, let's prove it. Let y be a set of the left hand side s minus t. So by definition of image, we have the x is x in s minus t such that y equal to f of x. So since x in s minus t, we have x in s and x not in t. Okay, x in s and x not in t. X in s and x not in x in s, so we have x in s, we then have f of x is in f of s, but x not in t, so we claim that x in t implies that f of x is not in f of t. And here's how this is true, because f is 1 to 1. Suppose is it not true, meaning that f of x is in f of t, then what happened? This means the x is small t is in big T such that f of x is equal to f of small t. Okay, since f is 1 to 1, we have x must be equal to t. Okay, x must be equal to t, but t in t, so x must be in t, and therefore x is in t. therefore x in t, which contradict to this x not in t. Okay, contradicts to the fact that x not in t. Okay, so our assumptions here is wrong. So we have f of x not in f of t. So this is a proof. Okay, so now we have y equal to f of x, y equal to f of x. So x in s, so f of x must be in f of s. So now we have y equal to f of x, x in s, so f of x in f of s. Since x is in s, we also know that f of x is not in f of t, as we proved before, as we just saw. F of x is not in f of t, so y equal to f of x not in f of t, so we have y in f of s, y not in f of t, and therefore y in f of s minus f of t. Okay, so we start here, y in this set, and we show that y in the other set. So we have this containment when the function is one-to-one. Okay, and we need to prove the other part. We need to show this one a subset of this one. B, we will show this. This one is subset of this one. Okay, so how to do that? Let y in f of s minus f of t. Okay, so we have y in f of s and y is not in f of t. Okay, y in f of s means that by definition of image we have means there is some x in s such that y equal to f of x. Y is not in f of t, and we will claim that this x is not an element of t. Okay. Okay, how? Suppose assume x in t, then y equal to f of x in f of t, which contradict to the fact that y is not in t. So y is not in f of t. Okay, so we know that now this x is not in t. Okay, so x in s and x not in t, therefore x in s minus t, and therefore f of x in f of s minus t. and y equal to f of x. So y in f of s minus t. So we start from here. We show y in there. So we have this subset. And we prove that. And we are done with the exercise.